Okay, anyway, I want you to take some notes. It's different, right? Yeah, you need to rename yourself, huh? Hello, you were not here last week. I was worried. Okay, you might be traveling, my guess. Not too sure. Okay, so yes, let's look at this now. Light travels at this speed in air. We all know. Okay, this is the speed that light travels in air. Then when a light ray enters a denser medium, its speed will slow down. Okay, so when its speed slow down, this ray, right, is called a refracted ray. It bends towards the normal. It changes direction. Okay, so either it bends towards normal or it changes direction. It is always because the speed of light has slowed down. Clear? So it's a slowing down of the speed that causes the bending of light, that causes light to travel in a different direction. So if you can take a look here, okay, this is the one that I'm showing, all right, in my text. So when light enters a denser medium, so it's moving from air. Air is less dense, water is denser. Okay, so when light ray enters the denser medium, its speed will slow down. Then the refracted ray is bending towards the normal. We all know the dotted line is the normal. Okay? Then the next thing, right? I repeat once more, light travels at 3.0 times 10 to the power 8 meter per second in air. If light ray enters a less dense medium, right, its speed will pick up. So when its speed actually increases, it's traveling faster, right? When it travels faster, it bends away from the normal. Must remember all these because in your open-ended question, you are also supposed to explain. Okay, what happens when light travels from a less dense to a denser medium? Or what happens when light travels from a denser to a less dense medium? Okay, you must explain accordingly. So when this happens, right, you see, here the light rays are traveling, or the light ray is traveling from oil, which is denser, to water, which is less dense. Okay, so it actually will speed up. So it bend away from the normal. Now, those are the quick summary. Let's look at our question 1. Which of the following is an example of a luminous object? Similar question you have last. So what is your answer this time round? Anna is here. So full attendance today. Very good. Do you all have friends? Do you all have friends who are interested to have tuition as well? If you all bring along a friend, right? Let's say you have some friends, maybe it was previous years, maybe it's a P6 last year friend not in the same school, but need some science tuition. Okay, you ask your friend to come, then both of you will enjoy ice cream. Or Haagen-Dazs ice cream. Each of you will get the voucher. Can? So I'm telling y'all now, it's the promotion, they are talking about it, but I'm telling y'all first so you can get yourself ready. If your friend will be interested, like Nikki, let's say you have some friends who are interested in having tuition, then you bring your friend to class, right? Then your friend sign on. Okay, then you get an ice cream voucher. Your friend also get an ice cream voucher. Sounds good? Okay, either that or, yeah, Hannah, I'm going to show you very soon, or you'll be getting the Golden Village, okay, movie voucher. Then you watch movie with this friend of yours. Okay, each one will get one. Yes, Nikki?
Miss, they will only than the Sec 1 student, not someone younger or older than you.
Also can. But I'm just thinking, okay, our class got 9 students, right? So we can build up the class as well. Some of the students told me they like to attend. My P6 class, right? There are like 4 or 5 of them. They are all good friends, They attend the same class, same session. So they're saying that it's quite fun to have friends coming in together. That's why I asked maybe you are keen. Yeah, because I heard got voucher, ice cream voucher, movie voucher. Why not? Get it lah, it's free. So just saying, Lord, if you have friends, if you don't have, it's fine. But Nikki, if you have friends who say that he or she wants to join a P5 class or a P4 or a P3, also can. Even the Sec 2 or Sec 3 also can. Doesn't have to be science, can be other subject, but they must not be existing student of 88 tuition. That's all. So you can think about it. Hannah, this is what we have gone through just now. So I was talking to them about the speed of light in air. Then we talk about how light actually changes speed when it enters from one medium into another. So in this first case, light ray enters a denser medium. So it was traveling from a less dense to a more dense medium. For example, I put the arrow here. Okay, light traveling from air into water. So less dense to more dense, the speed slows down. So it's always about speed slowing down. Then the light ray bends towards the normal. Okay, in your answer structure, you cannot say when light travels from air to water, okay, it bends towards normal. Then its speed slow down. Wrong. It should be speed slow down first, then bend towards normal. Are y'all clear? Everything that happens is due to the speed slowing down. Okay, this part here. So because the speed slows down and therefore the light ray bend towards normal. Okay, then it changes direction. So that's what we went through just now. So the opposite also holds. So when light ray enters a less dense medium, so I put an arrow here from oil denser to water, which is less dense. Okay, light will speed up and therefore it will bend away from normal. That's all. Okay, however, the third scenario, right? Nobody asked me yet. I was waiting for y'all to ask. Nobody asked. If light travels along normal, that means the light, right, is entering perpendicular into another medium. Okay? Take note. Okay, yeah. Even though the speed will actually slow down, okay, the speed actually slows down, right? But you don't see the refraction. Can you see that? Can you see that the light ray is traveling straight down? All right. So because angle of incidence is actually incident ray and the normal, right? But in this case, it's 0. So angle of refraction is also going to be 0. Is that all right? So that's all y'all need to know. I mean, I just summarized for y'all to take a look here. Okay? Nikki, all right? Good. Tammy, all right? Yeah, all eating dinner. Madhav had dinner already, right? Yes. No. In this case, the angle of refraction is 0 because it doesn't refract at all. So this is what I call the special case here because it actually went in, okay, at 90 degrees. Light ray is entering another medium at 90 degrees, not like the usual, they come in at a certain angle, right now. Okay? Only for this case. Yeah, only for this case. It's not for all cases, okay? Hannah, you know this, Yes, that is the law of reflection. The one that you have put down is the law of reflection. So you don't say in general, say this is the law of reflection. In case you are wondering. All right, so I type in now. If you see the chat, I put in the angle of incidence is equal to the angle of reflection. This is classified under law of reflection. Okay, this is the law of reflection. Not refraction. Refraction is totally different. It's due to the speed of light changing when light travels in different medium. Law of reflection, okay, we are talking about light rays in the same medium. Clear? In the same medium. So light rays is moving in the same medium only. Okay, so back to question 1. Example of luminous object. That means it can give out light on its own. Okay, the moon, the sun, diamond, our eyes. Which one? Answer can only be what? Answer can only be the sun. All of you got it right. Good. Okay, go on to the next one. Now, which of the following observations is not related? Not related to the speed of light. Okay, not related to the speed of light. So a straw inside a glass of water appears bent. Now, when the straw is inside a glass of water, you know that it has to be refraction taking place. Yes, that is related to speed of light. Okay, because speed of light changes. That's why there is refraction. That's why light bends. Now, we observe lightning before hearing the thunder. Okay, of course, yes. Why is it that we see the light first before we hear the sound? Because speed of light is faster than the speed of sound. Okay, so speed of light is faster than speed of sound. Now, many years back, we still teach the lower secondary students sound, okay, the chapter on sound. Now it's taken out of your syllabus. Okay, so you are studying lesser things already. Lesser and lesser and lesser. But when you go on to secondary 3, you will have suddenly a lot of things to study for science. Okay, I'm just preparing you all first. So you make sure your foundation is extremely strong in Sec 1 and Sec 2. Whatever that you didn't understand anywhere, be it in school, in tutorial, you can ask me. Clear? If you don't have a very strong foundation, you're going to suffer in Sec 3. Yep. Next one, swimming pool appears shallower than it actually is. Again, this is the same thing. So I can also say this is applicable here. Now, a beam of light shining through the window lights up the room. This is about window, which is made of glass, being a transparent material. Nothing to do with the speed of light. So therefore, D over here, okay, D over here is the answer, related. Why you all mark wrong? Why do you choose B? We observe lightning before hearing the thunder. Speed of light is faster than speed of sound, correct? But a beam of light shining through the window lights up the room. This has nothing to do with the speed of light, you know. Yeah. So I think the portal has some issue. Very sorry. Okay.
The mistake, it's a bit confusing because sees through the window light. So I thought if there's some refraction occurring if the light enters through the window. So I thought that is still related to the speed of light. So that's why I chose B because with the thunder, it doesn't seem to like
because y'all didn't learn about speed of sound, right?
Yeah, I didn't know about sound. That's why I think I just picked the B because it had nothing to do with the sound. I think not learned that in school yet.
Sure. But the fact that light can actually pass through the window, so it can shine through the window to light up the room, that tells us that the window is actually transparent, isn't it? So light can pass through. So has it got to do with the speed of light? Actually, no. Yeah, so answer is actually D. Answer should be D. I will take note and I will make sure the portal has it changed, okay? So those who answered D, right, like Ananya and Hannah, both of you are correct. Both of you are correct. So please write down. Okay, so if we are going to look at all this, okay, only this one is about material because the beam of light can pass through the window. Nothing to do with speed of light, really. Yeah, okay. So yes, let's go on. Question 3. Which of the following best describes the image that is seen when one looks into the curved, concave side of a shiny metal spoon? So concave is this side, convex is the bulging out side. So that's the spoon we are talking about. Now, If you are going to look into the spoon, this is not me, clearly not me, okay? I just took the photo from the internet. So what do you say? Which one is which?